This is for year 11 methods. We're going to look at extend response questions from the chapter 1 review. So we're looking at specifically question 1d. Now we've got a formula converting from degrees Celsius to degrees Fahrenheit. Now Fahrenheit's a temperature measure we use or is used in the US, while Celsius is what we're familiar with in the Australian system. Okay, so we've got x plus 10 degrees Celsius equals x degrees Fahrenheit, and we want to find x. Now, I would normally solve this question or solve this equation normally, which would be pretty simple. However, the complication is one side is in Fahrenheit, the other side is in degrees. So we've got to make sure both sides have the same units in temperature. Okay, so we got to either convert both sides to Fahrenheit or both sides to degrees Celsius. Since our formula is in terms of Fahrenheit, I'm inclined to try to make both sides Fahrenheit. Okay. Now we already know that the right hand side's already in Fahrenheit, so I'm going to leave that the same. It's only the left hand side that's a problem because we've got x plus 10 degrees Celsius. So in order to convert Celsius to Fahrenheit, I plug into the formula. So instead of C, which is our degrees, we've got x plus 10 degrees. So I'm going to sub in x plus 10 there. So in terms of Fahrenheit, x plus 10 degrees will be 9 over 5 x plus 10 plus 32 degrees Fahrenheit. Okay, so once we've set this up, it's pretty straightforward. We just solve the equation. Okay, solve it as a perfect normal linear. So I'm going to expand the bracket. So it'll be 9x over 5 plus 90. When I multiply a whole number by a fraction, you multiply the numerators together. So 9 times 10 is 90. 90 divided by 5 is 18. Plus 32 equals x. 18 plus 32 is 50. Okay. Now, the tricky part is getting rid of the fraction. Okay. So 9 over 5x minus 9 over 5x. Okay. So it's like saying 1 minus 9 over 5. You got to make sure the numerator is the same. Denominator is the same. So 1 is the same as 5 over 5. If I subtract 9 over 5 from that, I get negative 4 over 5. So if I subtract 9 over 5 from both sides, 9 over 5x from both sides, I get negative 4 over 5x. Okay, now I need to just solve this. Okay, I multiply both sides by 5. So 5 times 50 is 250. You're left with negative 4x on this side. I divide 250 by negative 4. You should get negative 62.5. Okay. Now, how did I do that in my head? All I needed to do is since I don't know what 250 divided by 4 is, I know what 200 divided by 4 is. 200 divided by 4 is 50. Now, we've still got a 50 left, right? So, a quarter of 50 is 12.5. So, if I add 50 to 12.5, I get 62.5. So, that's how I arrived at that answer. Just because the numbers are, slightly bigger, doesn't mean you can't do it in your head. So, I want you all to develop that competency to just break it down. No stress, just break it down and do it slowly. So hopefully that helps. You do need to work on your fractions if you're not comfortable with fractions still. This is a skill you need to develop to be able to do fractions quite quickly. Now you should be able to get to a stage where you don't even need to do baby steps on the side. Okay, you can do it in your head. Hopefully that helps you with this question.